one thing we can do with R when we examine the survey responses is actually to carry out a hypothesis testing. So in this video, I'm going to show you how we can do hypothesis testing for one proportion and also for one mean. So let's look at the proportion case first. We'll use the first question as an example. Here, that's the question about happiness. So how would you say things are these days in your life? And someone could say very happy. They could say pretty happy, or they could say not too happy. So nobody choose don't know in our case. And let's look at the distribution first again. So we created a table called happiness, and then we know that from the distribution we have 12 people choose 1, and 15 people choose 2, and 3 people choose 3. So actually the proportion of people who choose 1 is a little bit lower than 50%, but it's very close to 50%. Actually, I mean, it's 40% here. So 12 divided by 30, that's 40%. So here, one hypothesis we can test is to test whether the proportion of people who are very happy is less than 50% or not. So the hypothesis can be so we have the null hypothesis, which is P is 0.5. So that means we're setting the null hypothesis as equal to 50%. And then the alternate hypothesis is actually the proportion who choose yes or who choose very happy is less than 50%. So less than 0.5. So that will be the alternative hypothesis. So P is less than 0.5%, 0.5. And to test the hypothesis here, we set up the significance level. So significance level alpha equals to 0.05. So we set up the significance level as 5%, which means 1 minus alpha would be 0.95. And remember, we call this 1 minus alpha as the confidence level, and then alpha is the significance level. So let's see how we can do the hypothesis testing in R now. To do this, we will use the prop test function. So that's the function we use here. And it's a test function for proportions. So that's why it's prop. And to do this, we just need to specify a few parameters that correspond to our question. And then R will do the hypothesis testing for us. So you can see here we have to specify X. So X equals to 12. That'll be the number of individuals in the dataset who have the characteristics that we desire. And we know that we want to know the proportion of people who are very happy. So there are 12 people in the dataset that choose very happy. So X equals to 12 here. And then we specify the sample size, which is 30. And then we tell R the null hypothesis for the population proportion here is 0.5. So we're testing whether the proportion is 0.5 or not. So that's the population proportion, P equal to 0.5. That's our null hypothesis. And then we specify correct equal to false. So correct is basically a continuity correction in R. So we don't really need to have this correction for our analysis. So we choose that as false. Sometimes we have to specify this, but for our question, it's it's not necessary. Then we'll use the confidence level as 0.95. So in R, we don't have the significance level, so we will always use confidence level, but they are the same thing. So if confidence level equals to 0.95, that means our significance level is 0.05. And then we specify the alternative hypothesis because we're testing the hypothesis as p is less than 0.5 in alternative case. So we actually need to specify this as less than. So less, not greater. It depends on the hypothesis we're testing. So it can be greater. If it is greater, then that means the sign in the alternative hypothesis will be greater than 0.5. And it could be unequal to 0.5. P is not equal to 0.5. Then in that case, it will be a two-sided hypothesis testing. So if it is not equal to, then I will type 2 dot-sided. So that will be a two-sided hypothesis testing. Here, because we're testing less than 0.5, so that will be a less. And then we can run this whole line to carry out the test. And you can see here, so we get the p-value. So the result will be shown in the p-value. So the p-value equals to 0.1367. So it's about 13 or 14%, which is actually greater than 0.05, right? So we would not be able to reject the null hypothesis. And then we just conclude that there's no evidence to show that the null hypothesis is not true, or in other words, the sample evidence is not enough to show that the proportion is less than 5%, I mean 50%. So even though we get 40% in the sample, it's not enough to conclude that our actual population proportion is less than 0.5, which is 50%. I mean, the reason is that our sample size is a little bit small, so we don't have enough power to reject the null hypothesis and to accept the alternate hypothesis. So we just don't have that evidence here. And also you can see when you look at the result, we can get a 90% confidence interval for the proportions here. So the 95% confidence interval is from 0 to 0.549. So actually 5% is, so the population equals to 5% is within the confidence interval. So that's, this function can actually construct the confidence interval for us. We don't need to construct the confidence interval in this case. So we can just use this function to find the confidence interval. And that's for the sample proportion equal to 40%. And so that's for testing proportions. And we could also test a hypothesis regarding to a mean. So let's use question 30 here to look at how to test a hypothesis about means. So let's go to question 30. And question 30 is a question about the things about a job people value. So here's a question. So there are many things people value in a job. How important is each of those things to you personally? So we have a few things that are asked in the survey, and basically it asks people, okay, how important do you think it is to have a high-paying job? Or how do you think it is important? How important do you think it is to have a job, to have a job that is secure? Or how important do you think it is to be able to to take time off for family or children? So people can rank the importance in terms of extremely important, very important, somewhat important, not too important, and not at all important. So for each of the item here, they can have a rank in terms of the importance here. And because each person gives a rank for, suppose for this item, having a high paying job, then we can calculate the mean of the average rank, right? So on average, how people rank having a high paying job. Is that extremely important? If it's extremely important, then the average would be close to 1. If it is very important, then the average would be close to 2. And if it is somewhat important, like important but not too important, then the average would be close to 3, and so on and so forth. So we want to see whether the average is close to the middle or not. And so let's see what. Let me write down the hypothesis here, so that we can test whether let's choose what. So having a high paying job. So H now would be mu, which is the average ranking for a high paying job. So that'll be at item A, mu equal to 1. So whether it's important, extremely important or not. And then we can test this against the null of the alternate hypothesis, which is not very important. Meaning that the average ranking is not 1. So people don't think it's very important. It's extremely important. So if the average is 1, then that means it's extremely important. But if the average is not 1, that means people don't think that's extremely important. So let's test the hypothesis here. So to do that, we need to actually to find out the average of the rank. And to do this, we just use the mean function. So we use mean, and then we specify what the variable is. So it's a variable 30A. So that's the 30A question in the data set. So you can see here is 30A, and then some people choose 3, some people choose 2, some people choose 4, and some people choose 1, but not. I think that's only one person who choose 1, which is extremely important. And most people choose either 2 or 3, which is very important, somewhat important. And what we are trying to do is to find the average of the numbers here. So that'll be the average ranking of having a high paying job. And you notice here, so we have some data points equal to NA. So NA are missing values, so not available. So probably it is the person who answered the survey didn't respond to this question, so we don't have the data for that person. And when we calculate the mean in R, we have to to tell R to remove those missing values. So that will be the NA.RM. So that is NA missing value remove equal to true. So we're removing those missing values to calculate the mean. And if we run this, you can see we have a mean equal to 2.56. That is in between very important and somewhat important. So it's kind of a little bit important, right? So it's not very important, but it's a little bit more than neutral. So 3 is, you can think of 3 as neutral, so it's a little bit above neutral, but it's not very important. And then given this, we probably would say, okay, people don't think it's extremely important, because if we have the null hypothesis as equal to 1, that's very far away from the sample evidence, right? So probably we would be able to reject the null hypothesis. Let's see if that's the case or not. To test the hypothesis, we use the t-test. So t-test is the test for the means. And again, we need to specify a few parameters. In the first case, we want to specify the variable, and the mean of the variable will be the average here. So as we did here, so we use the average for question 38, and then that's the variable. And then we specify the null hypothesis, which is mu equal to 1. And then we specify the confidence level is 95%. In other words, the significance level is 0.055%. And here, because it's an equal sign in the alternative hypothesis, that's a two-sided hypothesis test. And we can run this whole line. And we get a very, very small p-value. So you can see the p-value equals to 1.311 e to the negative 9. So that's like there are 9 decimal places before the 1. So that's point 0.0000000. There are 9 zeros and 1311. So that's a very small probability. And again, that'll be less than 0.05. So we would be able to reject the null hypothesis in this case, and we can conclude that the average ranking is actually not 1. It's definitely not 1. So people definitely don't think having a high-paying job is extremely important. And that's how we can test the means. And in this video, we basically talked about how to test the proportion and how to test the mean. So to test proportion, we use prop test. To test the mean, we use the t-test. And that's it.